So here we have tetrahedron. And because each of those are half quantum, this must be one quantum. In other words, one quantum would be 6 vectors. Right? It's very interesting because this is also, if I want to have a system, I can't have an insiderness and outsiderness of less than 4 points. So the minimum, this would be minimum system. Tetrahedron is a system because it has insiderness and outsideness, and consists of triangles, therefore its structure. So this is then the minimum structural system. And also turned out to be 1 unit of quantum. This would be very impressive. We have a visualizable fundamental of our physics. Physics does not require such visual models, conceptual models. But I find there is conceptuality here.
In the final decade of his life, Buckminster Fuller finally emerged into the spotlight as a public intellectual. He's 75 years old in this lecture at Boston College, speaking to a young audience that seems just as confused by him as we are today. When Bucky says that the tetrahedron is 1 unit of quantum, is he speaking as a scientist or as an artist? Geometric figures are staples in abstract art, such as in this piece, literally titled Tetrahedra. Art is categorized as abstract when it represents an imaginary visual experience, using shapes and colors in surreal and fantastic ways. This often gives it a moral or spiritual dimension, since it depicts a reality that originates in our imagination. By contrast, conceptual art has a distinct idea or concept behind it. Instead of a moral or spiritual side, conceptual art conveys a kind of argument or proposition. Most of these works have documentation, like text or photographs, to further enhance the artist's intention. The artwork itself is like a vessel for the ideas that it communicates. In this context, I believe that synergetics is the pinnacle of conceptual art. However, because its geometry is so precise, it also appears abstract, since it isn't an accurate depiction of our visual experience. It shows us an impossible state of perfection that could never really exist in nature. Comparing synergetics to abstract art from the early 20th century, we can find some incredible overlaps. In Kandinsky's variegation of the triangle, for example, the use of color and shape are definitely abstract, while the numbers and precise angles in Bucky's triangle are conceptual. And its title clearly indicates that this triangle is part of a larger theoretical framework. That's exactly what synergetics is, a compendium of documentation for Bucky's conceptual art. Here's another example of what I'm talking about. This image is entitled Concave Octahedra and Concave Vector Equilibria Define Spherical Voids and Energy Trajectories. The spherical voids can be either the white spaces or the gray spaces, depending on your perspective. It's the classic M.C. Escher technique, where positive and negative space are interchangeable. But what sets Bucky's artwork apart are the claims he makes in relation to it, such as the spheres and spaces are rationally 1 quantum jump, and the total vector equilibrium spherical package becomes an export photon. These are intriguing propositions that leave us wondering how scientific they could possibly be. And it calls to mind the work of artists and philosophers who have done similar things in the past. A great example of this is Charles Leadbeater, a theosophist, who illustrated human auras in his 1903 book, Man, Visible and Invisible. On their own, these images qualify as abstract art, since they don't accurately represent our visual experience and must therefore originate in Leadbeater's imagination. But he goes a step further, by identifying each color with a spiritual affinity or emotional state, which exposes the conceptuality of his art. The conceptual scheme is even more explicit in this hierarchy of nature, where physical reality occupies the lowest point of dense bodies. Leadbeater goes on to apply his schema to various types of human beings. The entry for the scientific type of person is particularly interesting. In plate 20, we have no devotion at all, and far less than the average amount of sensuality, but the intellect is developed to a very abnormal degree. Affection and adaptability are both somewhat small in quantity and poor in quality, being apparently overshadowed by the intellectual development, as the man is not yet sufficiently advanced to possess all these qualities equally in their higher forms. There is a good deal of selfishness and avarice, and a certain capability of jealousy is also apparent. But the great feature of this man is the large proportion of golden yellow, showing a well-developed intelligence directed principally to the attainment of knowledge. A huge cone of bright orange rising in the midst of it indicates the presence of much pride and ambition in connection with that knowledge. But still the shade of the yellow precludes the idea that the intellect is debased to merely selfish ends. Now, I don't want to knock Leadbeater too hard on this, but he comes off as an angry charlatan in this passage. His contempt for the scientific type of person is particularly ironic, since he was writing this at the same time that Einstein was making breakthroughs in physics. It shows us how science and the arts were parting ways at the turn of the 20th century, which has had significant effects on the integrity of Western culture ever since. C.P. Snow famously highlighted the two cultures of intellectual life in 1959, with the optimistic scientific thinkers on one side and the literary existential artists on the other. Snow lamented the fact that highly educated people were still falling victim to an us versus them mentality, ultimately hindering social progress by splitting education into the humanities and the hard sciences. Bucky agreed with Snow's thesis, but had his own spin on it. He states, the tetrahedral model of the quantum as the minimum structural system of universe is a prime component in producing the conceptual bridge to span the vast chasm identified by C.P. Snow as having for so long existed between the 1% of the world people who are scientists and the 99% of humanity comprehendingly communicated with by the writers in literature and the humanities. So, according to Bucky, artists, generally speaking, are translators of scientific theory, and are responsible for preserving the integrity of a culture as it assimilates newly discovered knowledge. It's this very process of artistic translation that has been disrupted, which Bucky traces back to the discovery of electromagnetic radiation.
Very shortly after this, we come to electromagnetics. And suddenly energy is coming through a wire. Up this time, a man could see that steam, so there was something highly sensorial. But suddenly, energy is doing work going through a wire and making a motor go around, and you can't see what's going on. We have the literary man, the reporter, the writer saying to the scientist, please tell me, give me the model of what's going on there, because I have to have a model to describe. That's what I do. I describe models. I must describe a model to the public and tell them what's going on here. The public is going to be very concerned about the fact that I can send energy by a solid wire over here and do all that work over there. There's nothing going to affect them more. They've got to understand it. The scientist said, we're very sorry, but we can't really tell you about this because it's invisible and we can't see it ourselves. And all we know is that if you make another coil around here, then we get a different result. And what we do is it works in the magnet, moves a lever, and we get quantitative results by changing the cross sections of the copper wire and making so many wrappings, so many coils, and so forth. And it said we get on very beautifully arithmetically, and we can really now make predictions. We try to foretell in terms of those mathematical results. We sure they seem to be very, very reliable. So that we can get on all right here, but there really is no model. One scientist made the mistake of saying, well, something like water going through a pipe, and that's where the word electric current came from. And the other scientist jumped on it very hard because he said, this really is not a proper analogy, and the water won't run uphill, and then this current, if you're going to call it that, does go uphill, it goes anti-gravity. Pays no attention to gravity, apparently. So the scientists retracted back then, and then they made more and more measurements, and finally they came to one measurement where they found energy demonstrating a fourth power relationship. And with this fourth power relationship, they said, oh, we have X, Y, Z coordinates, and we have width, breadth, and height, and now And so this is one dimension, two dimensions, three dimensions, but we can't make a four-dimensional model. And because nature is demonstrating a fourth power-energy relationship, quite clearly she's not using models. And this made them feel great. They said, the generalized case for models is gone. We don't have to worry about models anymore. So the mid-19th century, science went off models. Now this has a very great relationship with what I've been talking to you about the scientist feeling. He doesn't have to worry about seeing the sun setting. He said, what I see means nothing to him. Models mean nothing. It's all a matter of figures. Nature's only using figures. Nature's using just mathematics. So we've gone through a century where science was saying that the physical universe is really just mathematics. There's no models. There are schematics which are very convenient when you're doing a problem, but don't get confused by my schematic at all. There's really not any model like that. Nature doesn't have a model like that. However, I became very excited in 1917 also, the idea that I said, I don't think nature has a department of physics, department of chemistry, and department of biology, and has to have a department head meetings to know what to do when you drop a stone in the water. I think she only has one department. I think she has only one coordinating system, and we're getting more and more powerful microscopes, and every time we do, I see nature has a model in it. She doesn't come to some threshold where she keeps right on with very beautiful patterns. They're very tantalizing patterns. So I think that physics is wrong, science is wrong in saying nature does not use models. And I'm very eager to find out whether we can't find what those models are, but I'm perfectly sure they're not going to be ghost cubes and so forth. They're going to be something to do with the vectors and energy behaviors. And so I began to pursue that kind of thinking. Now, that brought me into this topological, vectorial topology. And modeling has now developed an important way when I began to use tetrahedron as unity, obviously. And when you use tetrahedron as unity, volumetrically, and say that six vectors is one unit of quantum, then we find then the tetrahedron, which has those six, would have, say, is one unit of quantum, both in terms of the vectors, the energy represented by those vectors, and I'm going to call its volume as one.
From this point on in his lecture, Bucky is off to the races. His talks would sometimes drag on for 7 or 8 hours as he explored every nuance of geometric analysis. And this is a recurring obstacle for Bucky, since he never explicitly justifies his use of geometry before just diving in head first. Everything he does depends on the premise that the tetrahedron is actually the quantum unit. But at least we can now appreciate why he cares so much about these conceptual models. He believes that developments in science, particularly in physics, have remained artistically untranslated for 99% of humanity. This includes the discoveries of electromagnetics, which basically comprises all the discoveries of quantum physics. Bucky is striving to update our thinking by translating these discoveries into conceptual art. His demonstrations are an attempt to expand our conscious awareness into the unknown, just as electromagnetics forced us into dealing with invisible patterns of energy.
What do you do when you think? You discover that what you consciously do when you're thinking is not to start and light a bright light in a vacuum bottle, but what you do consciously is to dismiss irrelevances. That's your part. So that the thing that you've said, I'm going to consider, is the only one you do. Say that, never mind that telephone call, never mind the thought. Every one of us has had the experience of one another saying, what was our friend's name? We both, you say, I know, of course. And you can't remember it right now. Tomorrow morning, you're in the middle of a meeting and suddenly Fred Brown comes in there, and you didn't mean to look for it then, but the messenger comes back. You'd said what was the name, and some other hour, and Fred Brown came into my messenger, brought it back to me, interrupting what I was doing at that time. Once I discovered that my conscious part of thinking is holding off irrelevances and holding to one concept I'd like to hold in there, that what happens is then I find the irrelevances fall into two main classes. All experiences which are too large and too infrequent to in any way tune in with the relative frequency of the set that you're considering. Because I find frequency and size are the same phenomena. So it doesn't fit our size. And then there are all the irrelevances which were too small and much too high frequency to be able to even be differentiably readable at the magnitude that you and I are considering. So I found that all the relevances fall into the outward and inward set, the too large and too small, and because our experience is inherently omnidirectional, our observations this way and our Earth revolving, and therefore my dismissal must be omnidirectional. So I send the big ones outwardly in all directions, and I send the inwardly in one direction towards the common center from many directions. So this leaves me a lucidly relevant set that is clearly tunable. As we get to it, I also find in my kind of thinking out loud that I'm doing with you, you'll see me tempted time and again within the amount of time available that there is what I call a tantalizingly almost relevant. So because there is a twilight zone of inwardly and outwardly, and if I work fast enough, I just give you enough more to make it you begin to feel the way I do feel about the information we're getting. At any rate, this immediately produces a geometry for you. And there are a number of the points involved. It's always topological. It is a polyhedron, so many vertices, and there is our fundamental geometry.
Bucky's explanation of how we think is just like the scientific explanation of how we see. Visible light comprises a very narrow band of the electromagnetic spectrum. Until relatively recently in human history, we weren't even aware that there were invisible forms of light. It was just over 200 years ago that William Herschel made the unexpected discovery of infrared light. While graphing the relationship between temperatures and colors, he found that violet was the coolest and red the hottest, but was surprised to find an even hotter temperature beyond red. His graph showed the existence of some kind of invisible light, which is now infrared. One curious feature of Herschel is that he also discovered the planet Uranus, and he created illustrations of the Milky Way galaxy. In these illustrations, he uses 4 concentric spheres, just like Bucky's diagram of thinking, and like Flood's fourfold template of the cosmos. I find this to be a fascinating example of yet another pattern integrity. But of course, technology really did change everything. Just as telescopes revealed more planets and galaxies, spectroscopes revealed patterns of light, or any other wavelength for that matter. But these devices can only ever give us a false image of invisible radiation. When we use a thermal scope to see at night, infrared light is being transformed into visible light. A similar process occurs in astrophysics, where false color images are produced from the patterns detected by the Hubble telescope. I think Bucky is using geometry as the technological equivalent of telescopes and infrared cameras. Synergetics attempts to take what is otherwise invisible or untunable and make it visible or lucidly relevant. And this special function of geometry is crucial for modeling quantum physics, since it plunges us into a reality that can't be accessed through our natural faculties of perception. However, geometry does give us the impression of a false perfection, or false equilibrium, that could never really exist in nature. The ultimate symbol of this impossible equilibrium is the cube octahedron, or as Bucky calls it, the vector equilibrium. This title is extremely literal. Bucky's model of quantum physics uses vector transformations, the same approach used by Paul Dirac in his equation for quantum state vectors. So Dirac incorporated the previous work of Heisenberg and Schrödinger into a mathematical system that associates quantities to operators acting on vectors. But the vectors operate in Hilbert space, which relies on an XYZ coordinate system and would look something like this if we were to conceptualize it visually. Bucky's model uses 60-degree coordination, with 6 axes running through each vertex, not like the 90-degree Cartesian coordinates that we find in the Hilbert space vectors. The justification for this change in coordination is what I call Bucky's mathematical critique of the cube.
Bucky,
Yeah.
I want to be clear. The cube is the building block of the universe,
That's right.
and the square, it's lower order, when in fact the triangle is the building block, and the tetrahedron, so the triangle is the lower order, and the tetrahedron is the building block.
So the engineers have to keep putting in all these triangles to hold the architect's square buildings together.
Okay, yep.
When I went to school, they taught me then everything was made out of cubes. Teach architecture that, so. Nature is always most economical.
Yes.
Right? So if you're accounting the universe in cubes, you're taking up 3 times as much space as you would in a tetrahedron.
Yes, I got it.
And nature couldn't afford to do that. And she would not be very inclined to use that kind of a cube anyway, which had no strength. Inasmuch we find then that the tetrahedron is the minimum structural system in the universe, and it is the minimum way of accounting volumetrically.
Yes, I want one more thing, Bucky. If you start out with the cube as the volume of 1, what does it bring the tetrahedron out to?
All irrational numbers.
All the other shapes become irrational.
Yeah.
So then I just want to make sure that we've been clear about that. When you start out with the tetrahedron, all the other shapes then are rational.
They'll come out rational. So this way nature is doing her agglomerating, and if you do the tetrahedroning, structuring, and do things the way nature is doing in a structural manner, structural system, you're coming out of this beautiful rational whole number and doing it 3 times as more economical than the XYZ coordinate system, centimeter gram second system.
Yes, got it.
So which is, you're at school now, you're a scientist.
Yes.
Which one is nature using?
That one.
You bet. Which one are you going to use from now on?
That one.
What are you all going to use? Yeah.
The structure being gestured at on stage is a model of the isotropic vector matrix, or IVM. This is the 60-degree coordinate system that Bucky uses to model quantum jumps. The vector transformations within the IVM create a network of polyhedra, specifically tetrahedra and octahedra. These shapes fill space with no gaps in between them, forming what Bucky calls the octet truss. And here is where he makes a crucial theoretical leap, by considering the vertexes of the octet truss as spheres instead of points. This extends the IVM into physical space, which goes beyond how we typically think of coordinate systems. In high school, we learn about the Cartesian grid as a purely abstract model for graphing equations. This understanding translates to the octet truss version of the IVM, but not for the closest packed spheres model. The spheres represent the extension of points into space, giving it a physical reality that doesn't apply to the Cartesian grid or octet truss. For example, Bucky says the closest packing of spheres model coincides with the observed real world's atomic packing of like atoms with their own counterparts. So how does Bucky justify this leap from abstraction to reality? Well, he doesn't, not explicitly at least. By considering points as spheres, he is giving them spatial extension as separable objects. This preserves a degree of familiarity with our everyday experience, where a table is separate from a chair, which is separate from a rug, and so on. Einstein used a similar approach in his critique of quantum physics, describing it in terms of separability. In a letter to Max Born, he wrote, "The concepts of physics relate to a real outside world. An essential aspect of this arrangement of things in physics is that they lay claim, at a certain time, to an existence independent of one another, provided these objects are situated in different parts of space. Unless one makes this kind of assumption about the independence of the existence, the being thus of objects, which are far apart from one another in space, which stems in the first place from everyday thinking, physical thinking in the familiar sense would not be possible." Einstein's criticism highlights the fact that separability originates in our everyday thinking, and is therefore a necessary property of physical objects. But when we start thinking about quantum reality, this kind of separability begins to dissolve, up to and including the separation of an observer from their observation. This is most famously demonstrated in the double-slit experiment, where light behaves differently when it's observed. This goes against our common sense of how the physical world actually works. To counter this, Synergetics keeps a foothold in our everyday experiences by drawing on practical examples, like weaving, knotting, and spinning. These simple observations give us clues as to how things work at the quantum level, at least as long as we're willing to conceive of every dimensionless point as having a basic spherical domain.
The sphere, as defined by the Greeks, as a surface equidistant in all directions from a point, is non-demonstrable in physics and would be completely contradictory to entropy, because if it was a surface equidistant in all directions from a point, there could be no holes in it, because you came to the rim of the hole, there would be a changing radius. Therefore, it posits a complete separation of outwardness of the universe into two parts, outside the sphere and inside the sphere, with no connection between the two. Therefore, it could do away with the rest of the universe. It would be adequate to itself. It would not be part of the entropic and the anti-entropic kind of income outgo of energies we can experience everywhere. Therefore, I'd say that the only way we really can define the sphere today in the terms of what we know of physically of our universe would be an aggregate of events approximately equidistant, approximately all directions from one approximate event. That's the closer you get. And by the time we got to measuring these, there'd be a lot of things out of order. I mean, considerable discrepancies. So we only have them inherently a set of points, and the geodesics between those will bring about polyhedra. So this is what really brought me, as I got in my geodesic spheres and domes, into then these most economical relationships with the most points, and simply brings you back into an omnitriangulation. As you get into such very high frequency point interrelationships, then you get to beautiful observation, which is that I told you always take out, there's always that sinus of 720 degrees, which is to say that the sums of the angles around all the vertices of any system, no matter how complex, how spherical it may appear, will always be the numbers of vertices times 360 degrees minus 720. Always so. Therefore, the long-held concept that a sphere for an infinite moment was congruent with the plane to which it was tangent does not hold. Once you realize that there's this beautiful difference in here, I'll tell you then also I found the sums of the angles of any system, no matter how complex it may be, again crocodile, the sums of the angles around all the vertexes will always be a number divisible evenly by 720 degrees or by tetrahedron. Now we're getting this angular topology all of a sudden. It gets to be very, very powerful matter, and that every time is one unit of quantum. We're going to find some very beautiful coincidence here where conceptuality is beginning to come into our physics in a very, very important, powerful way.
Bucky's geodesic spheres are similar to diagrams of spherical harmonics. Spherical harmonics are the radiational equivalent of a sine wave, or a vibration that spreads out in all directions. These are special mathematical functions used for a variety of scientific projects, including modeling the magnetic and gravitational fields of planetary bodies. What makes Bucky's spherical systems unique is that the vibrations take place between the spheres, with the waves being directed along the fixed energy vectors of the isotropic vector matrix. As energy radiates omnidirectionally, it passes through layers of closest packed spheres, just as a wave travels through a material substrate. The math here is very basic, but hinges on the use of 60-degree coordination with the tetrahedron as unity.
We find that if you're counting space with cubes, you're using up 3 times more space you need to use up. If you're counting in terms of octahedra, instead of having, when you bring cubes together, you get this kind of the 90-degree angle at the center. But if you're bringing octahedra and tetrahedra, which are all 60-degree angles together, you get the hexagon. So you got six hours in your clock instead of 4 hours in your clock. That's going in one plane. But going omnidirectionally, you get much more in your clock. So you find that when you're using tetrahedra for unity, they will collect around a common center. Inasmuch as our universe and our experience is omnidirectional, we have then gravitational and radiational being convergent or divergent omnidirectionally. Therefore, we come to what I call a vector equilibrium. If you have a hexagon would be a common cross-section where these 6 vectors are all explosive forces going outwardly. Therefore, they become, the mass attraction decrease, they go off to be independent. But the same 6 are matched by 6 other vectors of the same value, and these are now end-to-end and continuous and come back to themselves. Therefore, they close themselves. Therefore, they're in a better arrangement, and they will hold it together. I find then that the implosive is always superior to the explosive. This makes a form when you take spheres, let's have just circles around circles. We get the 6 around 1, which is simply a hexagon. And you can get another sphere sitting up on top of here. There's a nest. And you get another one sitting on here. Another one sits on here. And I can get 3 sitting on the other side, where the other ones would be on the other face at one in here. We get 12 spheres around 1. When we do, we get, this is the closest packing of spheres. And that closest packing of spheres, 12 around 1, gives me what I call a vector equilibrium. And it looks like this. So we have, this is an omnidirectional vector equilibrium, and balancing just like that. We have the same amount of vectors holding the system together. They're the same value, therefore equilibrium, but this becomes a basic model of gravitational and radiational, where we're dealing in, had a circumferential and a radiational, which we have to always consider.
Using closest packing spheres to model structural changes of energy is an idea that we can find in the conceptual art of Robert Fludd. I showed this illustration in my previous video and want to revisit it now in the context of quantum physics. When Bucky was illustrating the flat hexagonal plane of spheres, he pointed out that there would be 3 nesting points on top. Here's that clip again.
And you can get another sphere sitting up on top of here. There's a nest. And you get another one sitting on here. Another one sits on here.
Fludd's illustration shows these 3 spheres that are perched on top of the hexagonal plane in those nesting points. Now, reviewing Bucky's Escher-type illustration of convex and concave polyhedra, we can also identify the central Hebrew letter He as the triangular face of a concave vector equilibrium. But there's more to Fludd's conceptual art here that becomes more relevant. This particular image falls on page 62 of a chapter entitled Divine Harmony. But on page 59 of the same chapter, Fludd gives us this image, which is a kind of simplified precursor that still shows us the 3 closest packed spheres and concave vector equilibrium. So the question is, what was Fludd trying to demonstrate to his readers by expanding this image on page 59 into this image on page 62? In Fludd's cosmology, God is symbolized in 2 ways: the 4-letter tetragrammaton and the Trinitarian Deus. So right away, we can see that Fludd has jumped from 1 to 2 symbols for God, and the jump is represented spatially as a kind of triangular extension. And this is where the concept of frequency enters the picture. In synergetics, frequency is based on size, determined by the number of spaces or quantum jumps between spheres. Zero frequency systems have only 1 space, and Bucky often states that 0 and 1 frequency systems are energetically identical. Only with 2 spaces do we achieve the first quantum jump of energy states. Traditionally, in quantum physics, frequency is measured in hertz, and specifies the wavelength of electromagnetic radiation. The energy of a photon, as determined by Einstein, equals its frequency, symbolized as v, times Planck's constant, symbolized by h. Planck's constant measures the minimum quantity of energy transformation for 1 quantum jump, and usually has a value of about 6.63 times 10 to the negative 34 square meter kilograms per second, although this has varied over time. But in synergetics, Planck's constant is equal to the beautiful whole number of 20. Here's how Bucky explains it.
there turned out to be eight tetrahedra in the total thing, and 6 1/2 octahedra, which gives you then a total of 12. The total volume of the vector equilibrium is 20. Where tetrahedron is unity, and unity for the vector equilibrium is 20. That is unity. When you look at cubes, you see the following pattern, where you now got the edge module is 2, then the volume of cubes is 8. 8 around the common center. When the vector equilibrium has an edge of 2, then it looks like this. Each of the triangles, each of the squares will be so subdivided. When you do that, its volume is 160. This means that your hexagon is divided like this. As what do you call it? The frequency of the system is 2. The radii and the chords are the same. The frequency is 2. When you see the square like this, you say it's 1, and then you say this is 2. But when this system reads 2, its volume is 160. 160 equals then 2 to the 5th power times 5. When you're using tetrahedra, you can make 4th dimensional models and 5th dimensional models, and actually make the models when you're using tetra or quanta. Because this now accommodates all that's been ever discovered dimensionally, energy-wise. So we find full modelability returning as we get into this, so that this suddenly makes it something very exciting coming up, and certainly in the industrial world of the television, that we find that modelability is returning here vectorially and coming out in beautiful numbers. Now, for a great many years, I found physicists, particularly the young physicists, very excited by this kind of relationship to find the regularity, but saying we will get nowhere until we identify Planck's constant. And said, where does Planck's constant fit in here? And I didn't really know until this last year I suddenly found it. And it got to be very exciting, because if any of you are students of Planck's constant and get into all the different experiments made, Planck's constant, there are quite a few different numbers that have come out by different physicists in very reliable work, approximating one another, but that number will be 6.65 or in this vicinity here somewhere, and then they have this times minus 10 to the 27th power. And this is times 1 gram, which was a gram being the cube of water, and 1 gram second. And the amount of expansion you would get, because a gram second to the 2nd power. And to the 2nd power, because as Einstein, when your radii are increasing, they're the linear, then the surface will be increasing the 2nd power of the linear. And therefore, Einstein's radiation constant of C to the 2nd power, because it isn't just going linear in vacuum, but it's expanding as a wave as light does in all directions. Therefore, C to the 2nd power. Same way, then, the gram seconds are given in terms of the 2nd power, or the rate at which the amount of energy in this cube gram, starting reference to water in the old days, can be expanded. And we have Planck's constant as the figure of convenience to explain the radiational results in the terms going back to the centimeter gram second system. Well, then you get to a cube, mind you, as a basic cubic centimeter, and of a specific weight. Now, the relationship of where unity is, they used to have unity in the terms of the cube, but I find it is in terms of the tetrahedron. But as far as radiation goes, it is the vector equilibrium, and the vector equilibrium is the value 20. And the cube we find is a value really of 3 in that system. So the relationship of 3 to 20 is, our friend, 6.666. Now you'll find that the gravitational constant, all the measurements of gravitational constant are always just a little better than the 6.666. And the radiational constant just runs a little bit less. All of them, they come in somewhere in here. So if we add the two together, all the averages, they'll come out, our friend, 6666. And as they simply find that they're simply, here is then the system fitting in with here vectorially and quantity-wise. So that the gravitation seems to be a little more effective than the radiational, and the very integrity of our universe seems to be implicit here, by virtue of the arrangement of the vectors.
So just to review Bucky's reasoning here, Planck's constant comes out to an irrational value, approximating 6.66, because it was arrived at by dividing the tetrahedral volume of the vector equilibrium by the tetrahedral volume of the cube. And this mistakenly took the cube as unity, when in fact it is the tetrahedron. Meanwhile, the vector equilibrium is unity in regards to the minimum energy transformation for one quantum jump. Bucky states that Planck's constant, while identifying a hitherto undiscovered invariant limit condition of nature, was described in the wrong frame of reference, in awkward, albeit in a constantly awkward term, which works, because it is the truth. But at the same time, it befogs the otherwise lucid and rational simplicity covering this phenomenon of nature. In synergetics, the energy of a photon is equal to 20 times its frequency squared. As Bucky mentioned briefly in the last clip, the frequency value is squared for the same reason that the speed of light is squared, in E equals mc squared. Radiation isn't linear, but expands circumferentially. Bucky's equation therefore has yet another similarity with Paul Dirac's equation, which was a breakthrough because it combined Planck's constant with the speed of light, according to special relativity. Going back to Flood's illustrations, we can see that he was trying to represent the 17th century equivalent of one quantum jump. Going from 0 frequency to 2 frequency means expanding the triangular surface of spheres, creating a vector equilibrium of greater size. I've added in the spheres and their vectors here to highlight this transformation, which combines the octet truss structure of the IVM with the physical separation between the spheres. Another way to visualize this relationship is to superimpose Flood's pictures on the triangular face of this vector equilibrium, which of course would be one frequency or size larger than what Flood has shown us here. I'll be offering more context for my interpretation in the next video. But to summarize Bucky's theory of quantum physics, it seems that he selected the tetrahedron as the quantum model for aesthetic reasons. Synergetics expands on this fundamental premise to produce a beautiful system of geometric relationships, supposedly encompassing all of our physical knowledge. One of Bucky's grand assumptions about the epistemology of science is that we should find scientific knowledge beautiful. Or more specifically, we should be using the beautiful whole numbers that nature is using. So this synthesis of beauty and rationality is Bucky's way of bridging the chasm between art and science. The tetrahedron makes physics more aesthetic by reconceptualizing its ugly irrational values, like Planck's constant, and revealing their geometric foundations. Traditional physical constants have worked because they're technically true, but have ultimately led humanity astray by obscuring the reality that they were supposedly describing. Bucky starts with the tetrahedron in order to rediscover the conceptuality of generalized principles. This is what he wants all of us to realize. Discoveries are uniquely regenerative to the explorer and are most powerful on those rare occasions when a generalized principle is discovered. When mind discovers a generalized principle permeating whole fields of special case experiences, the discovered relationship is awesomely and elatingly beautiful to the discoverer personally, not only because, to the best of his knowledge, it has been heretofore unknown, but also because of the intuitively sensed potential of its effect upon knowledge, and the consequently improved advantages accruing to humanity's survival and growth struggle in universe. The stimulation is not that of the discoverer of a diamond, which is a physical entity that may be monopolized or exploited only to the owner's advantage. It is the realization that the newly discovered principle will provide spontaneous, common-sense logic engendering universal cooperation where, in many areas, only confusion and controversy had hitherto prevailed. In my third and final video of this series, I will be taking a closer look at a major controversy from the 17th century. Johannes Kepler and Robert Fludd were locked in an argument about cosmology and how the human mind can comprehend the works of God. It's thanks to one of the great quantum physicists, Wolfgang Pauli, that the Kepler-Fludd polemic was revitalized over the past 50 years. And now it's time to see what Bucky has to offer in this 400-year-old dispute.